So, again, we're going to start on page 641, all right, and we're going to talk about something that's a relatively new topic to geometry since we started teaching Common Core, okay, which you guys might be like, well, who cares, we're in Common Core, so we're going to learn it anyway, right? So, anyway, the topic here okay, is going to be subdividing a segment in a given ratio. Okay, so the essential question we want to be able to answer is, how do you find the point on a directed line segment that partitions the given segment in a given ratio? Okay, so basically what we're going to take is we're going to start with a segment, right, which we know segments, right, we learned about segments way back at the very beginning of this class. Segments are like, they're like lines, but they have a starting point and a stopping point, right? They don't go on forever in any direction. They have a starting and stopping point. And we're going to break that segment, okay, into into parts that are going to be in a given ratio. So, for example, we might break it into like a ratio that's got like 1 part to 1 part or something like that, or 2 parts over here and 1 part over here kind of thing. So that's what we're going to be doing here, is breaking up a segment into ratios. Okay, breaking up into like equal pieces in a way. Okay, so we're going to look first of all at a one-dimensional, so just like a number line. We're going to try and break up a segment in this way, kind of like using a number line, okay? So it takes just one number to specify an exact location on a number line, right? A number line, if you got one number, you can know exactly where you are. For this reason, a number line is sometimes called a one-dimensional coordinate system because you only need one number, okay? In the coordinate plane, how many numbers do you need to figure out your location in the coordinate plane? You need 2, and so that's why the coordinate plane is called two-dimensional. Okay, you have like an x and a y part, but here it's just one-dimensional because there's only one number you need to figure out where you are. Okay, the mile markers on a straight stretch of a highway turn that part of the highway into like a one-dimensional coordinate system. I don't know if you guys ever noticed, but when you're on the highway, right, there are these little like small green mile marker signs as you're driving. That helps, emergency crews know like where to locate you. If you like break down the highway, you can say, "Oh, I just passed mile marker, 72 or something like that." Most people don't see them, but they are like on 70, on 270. It might not say mile 1. It might just say like a 1. I'm not sure, but they do. They're very small. They're very small. Very small. They do say mile? Oh, there you go. So anyway, on a straight highway, the exit for Arthur, and so this is like now our situation. On a straight highway, the exit for Arthur Avenue is at mile marker 14. Okay? The exit for Collingwood Road is at mile marker 44. The State Highway Administration plans to put an exit for Briar Street, again, another made-up road, that is 2/3 of the distance from Arthur Avenue to Collingwood Road. Follow these steps to determine where the new exit should be placed. Okay, so we're going to mark Arthur Avenue, point A, and Collingwood Road, point C, on the number line. All right, so here's our number line, right? We can kind of like see our mile markers here. So Arthur Avenue was at mile marker what? 14. So on our number line here, there's 10, so there's 11, 12, 13, 14. So this right here, that's going to be point A. Okay, that's point A. We were told here that Arthur Avenue is at mile marker 14. So Arthur Avenue is at 14. Okay? And let's see here. The exit for Collingwood Road, which we're going to call point C, is at mile marker 44. So Collingwood Road is at 44. So here's 40. So 41, 42, 43, 44. Why do you say 34? Oh, because you want to like...
I did 44 minus 14 and then divided that by 3.
Oh, okay. We're going to get there. You're a step ahead of us. Yes. Yeah. We're getting that. Right now we're just marking the exits down. So yeah, that's all. Okay. So yeah, letter B then says, what is the distance from Arthur Avenue to Collingwood Road? Again, this was a coordinate of 14. This is a coordinate of 44. What is the distance? How can we find that out, Kyle? 30. How'd you get 30?
44 minus 14.
Yeah, the distance from 14.
No, because I thought we had a ruler.
All right, so, well, we're going to use the coordinate. We're going to use the ruler later. Right now,
That's what I said last one.
okay, so 14 to 44, that distance is a distance of 30.
30.
Okay? So I think my explanation is good enough with the math there.
Why wouldn't it be 14 minus 44?
Well, because when you're trying to find a distance, you really don't ever talk about negative distances, right? So you could do 14 minus 44.
Yeah, but I know it wouldn't.
It would be then, but you do the absolute value of 14 minus 44, and then it would give you still 30.
Okay, like...
You make it positive.
It doesn't make sense, it's like 14 times 44 off the line.
Right. But, you know, and again, distances, you always want to talk about being positive. So you could do it that way, but then take the absolute value, that's all. Okay? Because we'll still get to 30. All right, now, how far will the Briar Street exit be from Arthur Avenue? So the total distance is 30, but this exit, they want to put the exit at a point that is 2/3 of the distance. So that means we want to find, what do we have to do to this 30?
Oh, you have to put
Divide by
it in the 2 and divided by.
Divided by 3.
Okay, well, divide that, so we could divide by 3, and then what we have to do, though, after we divide by 3? Times 2, exactly right. So you could divide by 3 and then multiply by 2, or you could just multiply by the fraction 2/3. That's another way to do it, too. We could just do 30 times 2/3,
Yeah, that's right.
which would give you then 20.
Wait, how do you do that one?
Why are you multiplying?
So, again, in the directions, because we want to know, so where is Briar Street? What's the information we're told? The State Highway Administration plans to put an exit for Briar Street at a point that is 2/3 of the distance from Arthur to Collingwood. So 2/3 of the distance is 2/3 times the 30 there. So that's it, 2/3 times 30 would give you the 20. So the Briar Street exit is 20 from Arthur Avenue.
So, like, if we didn't have the instructions, and it was like, how far would blah, 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 blah. So,
I will go.
you would find the distance between those 2 points,
Yep.
and then multiply it by whatever they give you.
Whatever the fraction of the distance, exactly right. Yep, okay? So, what then, so that's our distance, what is the mile marker number, though, for the Briar Street exit? And let's go to Krishna. What would the mile marker, yeah, what would the mile marker number be for the Briar Street exit? 40? 20? So 20 is the distance. How far will the Briar Street exit be from Arthur Avenue? So 20 is the distance from Arthur Avenue. What's the marker going to be? 34. Yeah, we're going to start with the Arthur Avenue coordinate. We're going to go out the distance away the exit will be. Oh, sorry. Thank you. We're going to start at the Arthur Avenue coordinate and then add to it the distance that the Briar Street exit will be, and that gives us, yes, 34 is the mile marker. And then plot and label it. So let's see here. So 34, there's 30, 1, 2, 3, 4, and label it B.
14.
Yep, it was 14 plus the 20 there. We have to start at the exit, at the Arthur Avenue, and we add the 20 there to it to make it 2/3 the distance. So you can see now this point B, okay, does it look like that's about 2/3 of the full distance there? I'd say so, yeah, right? That looks like it's about 1/3, and so that would make, this then about twice that, so 2/3 of the full distance there. You can kind of see it, okay? So again, let me kind of show that. This is like 2/3 the distance of AC.
Wait, so we have to draw that.
If you don't want to, you don't have to. It's just part of the notes, that's all. Okay? That's 2/3 the distance of AC. And this then would be what fraction of the distance of AC?
1/3.
Yeah, 1/3 the distance.
What does it say distance for?
Distance of AC.
What?
That's right. Air conditioning. Okay?
Why is 1/3?
Just to show that, because again, if this is the full distance from A to C, if this is 2/3, then the other piece has to be 1/3, the remaining part, to then make it a full one. Okay? So there's that. And then, yeah, we're going to skip that next part, and we'll just move into partitioning, because I want to move on here to some actual, problems and stuff, so. Okay, so let's take a look here at page 642. So here's what we're going to be, how we're going to be using that kind of idea then. Okay. So we're going to talk about now partitioning a segment in a two-dimensional coordinate system. So like what we see here, right? 2 dimensions, x and then a y coordinate there. So a directed line segment, you kind of guys maybe heard me use that phrase before. A directed line segment is a segment between 2 points, such as like A and B, with a specified direction. So in other words, like from A to B or from B to A, right? Those are like, that's the direction, okay? So from A to B is like going from here to there, and then from B to A would be starting at B going to A, okay? To partition a directed line segment, partition just means to like break it up into equal size, or into pieces, okay? Not necessarily equal size pieces, but to break it up into pieces. To partition a directed line segment is to divide it into 2 segments with a given ratio. Okay? So, for example here, we want to find the coordinates of the point P that divides this directed line segment from A to B, in the given ratio. Alright, so here's our coordinates for A, -8, -7, there it is plotted, and then 8, 5, there's the coordinates for B, 8, 5. You'll notice here that, for example, the y coordinate for B, the 5 is halfway between 2 grid lines there, and that's because they're counting by 2's here. 2, 4, 6, 8, so 5 would be halfway between the 4 and the 6 there, so that's why it's like a halfway mark. Same here for the -7. The -7 is like halfway between the -6 and the -8, so that makes that -7 there. Okay? Shh. All right. So those 2 points are plotted, and we want to find the point P that divides this segment in a ratio of 3 to 1. That means this point P, wherever it goes on here, the part that's between A and P, so from A to P, you need to have like 3 parts, and from P to B should be 1 part.
And how does it?
Because that's what we're told here. The ratio wants to be 3 to 1. So we're going to break this up so that, like, sorry?
How come the B to A? Why is that not 3?
Because it's a directed line segment. We're going from A to B. From A to B. So we have to start at A. We want to go 3 parts to wherever that P is, and then there's going to be 1 part for the remaining part. 3 to 1. So from A, it's going to be 3 parts. A to P is 3 parts, and then P to B is 1 part. Okay? So if there's going to be 3 parts on this side of P and 1 part on the other side of P, how many total parts are we talking about? 4 parts, right? There's going to be 3 parts on the one side, 1 part on the other side. So there's going to be 4 total parts. Okay, 4 total. And then, so that's going to be our bottom number, because that's our total. And then we want to go from A, we're going to go how many parts to get to P? So again, we need a total of 4 parts here, and to go from A to P, we need to go how many parts? It's 3 parts, right? That first number is 3. So we're going to go 3 parts. So this is the fraction. We want to find this distance, the 3/4 of the distance from here to here. 75%, yeah, 0.75, yeah. So again, the idea is that P is going to break up this segment so that there's 3 parts on one side of P and 1 part on the other side. So that means 4 total parts, right? 3 on the one side, 1 on the other side. So the total will be 4 total parts. Like, well, P's not drawn yet, so you can't see it as far as like that. But we're told 3 to 1. So yeah, you add the 3 and the 1 to get the total number of parts. And then we want to go in 3 of those total 4 parts. And that'll break it up into 3 to 1. Okay? So we want to do 3/4 of this distance. Okay? So, that's a diagonal distance. That's pretty hard to do. Instead, we won't do the diagonal distance. We'll do 3/4 of the rise and 3/4 of the run. Okay? So, what's the rise here? How high am I going? From A to B, how much are we going up here? So we start at -7, and we go up to 5. So yeah, it's 12. Okay, you can kind of see that right here. The rise is 12. You can see it right there, and they've calculated for us.
How did you get 12?
How'd you get 12, Kyle?
I just added 5 and 7.
So yeah, so it's like a distance of 7 here, this way, from 0, right, that's like from -7 up to 0, that's 7, and then from here up to then to the 5, so it's 7 plus the 5 to get that total rise right there. This is 7, and then that's going to be 5, so 12.
Can you go over that, because like,
Sure.
that is not clear.
The y coordinate here, right, this y
Why
coordinate,
is it just that little section? Why isn't it that entire line?
It is the entire.
well, so that's why we have to add the 7 plus the 5 here. This, the y coordinate here, is -7, right, so that means this distance right here is 7, a distance of 7. And then the y coordinate,
You're not going all the way up. Why are you just going to the x line?
because when you have a y coordinate, it's always measured from the x-axis, right? You always count down from the x-axis.
So then why aren't you doing 1/4? Why are you doing 3/4?
Because 3/4 is the fraction we want to go from A. We want to go 3/4 distance from A to B.
Yeah, but why are you picking 3? Why can't you pick 1?
You could do it that way, but see, the idea is since we're going from A to B, then we need to do 3/4. If we were going from B to A, then you could do 1/4, if that makes sense
So
now.
so what's your next step? You're
So-
just picking random.
We're figuring out the rise, the total rise, and we're going to figure out the total run here. So the total run, again, it's 8 to here, and then another 8, so a total of 16. So that run 16, the rise is 12. Okay, so far so good? Now, I don't want to go the full run, I want to go what fraction of the run? 3/4. I want to go the full rise, I want to go what fraction of the rise? 3/4. So we just want to do 3/4 of each.
So how do you do that?
Well, let me show you, it's really easy.
3/4 times.
You just multiply. 3/4 times the 16. To get 3/4 of the run, you do 3/4 times 16, so 12.
Yeah.
To get 3/4 of the rise, you do 3/4 of the 12, which is 9. And so then from A, we count a run of 12. So we go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's our run. And then we're going to count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's point P.
Like, why are you counting like that?
The reason is because if you look at the scale here, Ikeba, and everybody else, these tick marks are counting by what?
I know, they're counting
By
by 2.
twos. So when you count, for example, the run of 12, we can't just count the individual grid marks. We have to count the in-between
Okay, so like,
as well.
like I want to count by 2, but it doesn't start on an even number.
Yeah, exactly. That's why I was counting by ones.
But what if I want to count by 2 so it's easier?
Well, so for example, you want to do like the rise from here, basically, count by twos. So you can. You'd be like,
I want to do a run.
oh, the run by two. So the run is easy because the run does start on a grid line. So it's 2, 4, 6, 8, 10, 12.
Okay.
Right? And you're going to count up 9. So you can go like 2, that gets you to the next midpoint. 4, next midpoint. 6, next midpoint. 8, next midpoint. But then you have to go up one more to get to the P there because you make 9.
So, I mean, on the run line,
Yep.
it's in the middle of squares, so
Yep.
it's not on a grid line.
No, but you could make it because that distance is from here to here is 1. So it's like 1, and then 2 more is 3, 2 more is 5, 2 more is 7, 2 more is 9.
Okay, so what's that point on? So it's on -8, -7, right?
Yes. Started there.
Like, I guess I don't understand why, like, there's just a random point in the middle of the square. Like,
Which, I'm sorry, I'm not sure
Like
what
on the
random point
run
you're talking
line,
about. Oh,
like-
right here?
on
Or right here?
the
Like this thing right here?
yeah.
This coordinate you're saying right here?
It doesn't matter.
They're making a triangle. Here, let me show you this one. I think it'll maybe make more sense when we actually go through the full problem ourselves rather than like what they're doing. Okay? So let's try this one now. So letter B, we want to take point A, which has coordinates -4, 4. So let's plot point A. Yes, go for it. And then plot point B, which has coordinates 2, 1. Now this is nice because it's not counting by twos anymore, so this will hopefully make things a little bit easier too, and that's point B. Okay, if you want to use your rulers, I'm going to use my little straight edge here. You can make a nice straight line. Okay. And again, we want to write a ratio from A to B. We want to break this segment up so that it's one part to the left of P, or one part between A and P, and then 2 parts to the right between P and B. So P is going to have one part on this side and then two parts on this side. All right? So, what fraction then, what's the total number of parts that's going to be in this segment? 3. Yeah, 1 plus 2 is the total number of parts. It's 3. And then we want to go what fraction from A to B? We want one part on that side, so it's going to be 1/3 is going to be the fraction. Okay, that's the key right there. We want to go 1/3 of the distance from A to B. Okay, you can kind of see that. Yeah, I'm not going to bother with it. Okay, so again, there's 3 total parts, and we want to go 1/3 because that first part's 1. So 1/3. So yeah, yep, that's right. So let's figure out our rise and our run here. Okay, so from A to B, what's our rise from A to B? -3, right? Because we're going down 3 in this case.
Why is it?
Because we're going down 3.
Oh, I know that. I'm thinking, why is it 3? Like, why is it -3? Why is it?
Why couldn't it be 3? I mean, it could be, but again, we're talking about direction here. It's going down 3 and then right 3, so it's kind of like, in a way, it's kind of like the slope.
I was so, like,
Oh yeah, I see what you're saying. But you understand now, we're going from A to B because we're told
I
that.
would go up 1 instead. Like,
Oh, you would do like the triangle this way?
no, I would go up 1.
What do you mean by up
I don't know
1?
how you get -3.
Because to get from A to B, we have to go down 3.
Why can't you, I mean, I know you can't go up 3 because the graph doesn't go up there, but if the graph went up there, would you go up 3?
Yeah, exactly. It's because we're going from A to B. To get from A to B, we have to go down 3, and we have to go
And
right.
you're getting the 3 and then 9.
Well, this is separate. I'm just counting the rise here. We're going down 3 to get from A to B. And then we have to run 1, 2, 3, 4, 5, 6. So a positive 6 because it's going right 6. So down 3, right 6. Okay?
Where are you getting 6 from?
To go from A to B, we have to go 1, 2, 3, 4, 5, 6. Just count the boxes, yeah. Shh.
Wait, you get the 3 on the top and 6.
Okay, we're just counting the rise and the run. That's the rise, and that's the run.
Wouldn't that be -6?
We went from left to right, so it's still positive 6. Shh. Okay, now, that's the total rise. Do we want to go the total rise? No. What fraction of the rise do we want to do? 1/3 of it. So we're going to do 1/3 for the rise. We're going to do 1/3 times that -3.
It's already like pretty much easy for you.
It is. There are very nice numbers here. You're exactly right. And the run is going to be 1/3 of what?
1/3 of 6.
Of the total 6. Okay. So 1/3 of -3 is -1. 1/3 of 6 is 2. So that means our point P is going to be a rise of -1. From A, we're going to go rise -1 and run 2. And there it is.
Yep, I was right. I just
That's
asked.
it?
That's it.
You could just look at it and tell like which one it's gonna be.
You can kind of see it, yeah.
Yeah.
Yes, Ikeva, sorry. Yeah.
Technically, you could go up, though, instead of going down, maybe.
You could go from B to A, you're saying? Is that what you're trying to say?
No, I'm saying, like, if you put your pencil on A.
Yes.
And you go right,
Right.
and then you go down.
Yes.
That would be the same thing.
Yes, exactly right. You could do the triangle that way too. Yeah. Yes. Sorry.
How do you get -1?
1/3 times -3 is -1. So then our, that makes this go that way, and then that, there it is.
And why is the point like 2, 3?
Say it one more time, sorry.
I said, why is the point like 2, 3, 18?
So it would be -2, +3 is the coordinates for P.
So how do you get that?
So we got that from, first of all, let me explain how we found P, right? So first of all, we saw from A to B, we had to rise -3 and run 6, right? That's a total distance. We don't want to go the total distance. We want to find the point P that goes 1/3 of that distance, right? Are you okay with that? Okay, so what's 1/3 of that total -3? It's -1. So that means instead of rising a total of -3, I actually want to rise only a -1 to get to P. And then to run, I don't want to run the total of 6, I want to run 1/3 of that, so 2. So I'm going to rise -1, run 2, that gets me to this coordinate. the coordinate of point P is -2, 3. Okay? So that's the coordinate for point P, but how we found it is we used a fraction of the rise, a fraction of the run. We went down 1, right 2. That gave us point P, but then that has coordinates -2, +3. Is that clear for you now, Zaria? Okay. So what, Jason?
Now I got it.
Yeah, I figured not, so you probably put your phone down. Yeah, I can come have you come in. Sure. Okay, so there's point P. Let's, of course, you don't give me any graph paper there. Bummer. All right. Well, we'll hold off on that one. Let's try a different one here. So, alternative to these, all right, so for example here, we're going to try something different. So, if you guys have your rulers out, we can do this another way. Okay? So let me show you guys a different option. If you don't like that way, let me show you a different option. Okay? Let's go back up here to this original one. Okay? If you take your rulers and we measure the full distance here. Okay? What would we say in centimeters? What would we say is approximately the measure there? If you guys can see, let me see if I can get that to work there.
I would say 4.
Okay, well, the full distance from A to B, I would say about 4.2 or 4.3. Okay, I think for what I see here, it looks like more like 4.2. I want to say. Okay. Well, let's see. So you say 4.3, and I'll say 4.2. So let's say the full distance here is 4.2, or we can also check 4.3 as well. 4.2, right? If we remember, did we want to go the full distance from A to B? We did not. We wanted to go. Remember, I said we wanted to go 3/4 the distance. That was for part B. We're doing the other problem now. This problem is 3/4 of the distance. Okay? This is part A. The ratio in part A was different. The ratio is for part A is 3:1, which then gives us the fraction 3/4. In part B, the ratio was 1:2. That gives us the fraction 1/3. So that's why it's different here. All right. So 4.2 is the full distance. If I only want to find 3/4 of that, I can take my calculator here. Do 4.2 times the fraction 3/4, and I get about 3.15. Now, watch this. If I measure from A to B, if I measure out 3, so there's 3 right there on my ruler, there's 3.1, there's 3.2, and look where P is. It's right between where the 0.1 and 0.2 would be. That's where 3.15 would be, right there. Okay? So instead of doing all of that, you can just take the 4.2, multiply by the fraction 3/4. We get about 3.15, and then you just measure on your ruler out 3.15 and make this mark, and there's where point P should be. Okay, so P is 3.15. Okay, so there's another option. Yes, Ikawa.
So I got 4.3.
Okay.
Which would make 3.225.
Okay.
So
again, because the way you did that, it's going to be, again, I mean, you could see there about 3.2 is again where it's going to be. It's going to be on a grid line for the most part, okay? I don't think I'm going to give you guys any that don't end up being on grid lines, okay? So just kind of, I would say, go to the nearest grid line, is what I would say.
so it's never going to be not on a grid line?
For the problems that I'll give you for like a test or a quiz, no. For the problems in the book, it might be that way, but for a test or quiz, you won't have to worry about it not being on a grid line, okay? All right. And then if you want to check yourself, you can use this other method you're looking at too. All right. And look at part B here. Same thing. If I measure from A to B, okay, if I measure from A to B, I get about like 2.8, 2.9 maybe.
For part B?
Yeah, for part B, I get it like a full length here from A to B of about 2.8 or 2.9. Okay, well, so you can say 3 if you want.
Yeah, but it's like, it's the same measure, like, the point, the same dot. Like,
Right.
Why would you get 2.8 and I got 3 if they're the same thing?
Not sure. One of us is maybe measuring it a little bit different than the other, I guess. Maybe it's how you're placing it, because it is kind of like different. Okay, I mean, like, it depends on how big you make your points.
Do you want me to place it on this line, or do I place it on the one?
The point.
No, nothing.
Yeah.
I'm talking about my ruler. Where do you...
Oh, you always start on the line, not the edge of the ruler. You want to start at the 0. Start at the 0.
Not a 0 on my ruler.
Doesn't say 0. Okay, well, the very first line there. Yeah, the very first line is what you want to use.
Like the centimeter line, it says centimeter?
Yes, exactly. Okay, so there that is. So again, that's the full length, is about 2.8 or 2.9. But again, we don't want to go the full length. What fraction of the full length do we want to go in this one? We wanted to go 1/3. That means we're going to take that 2.8 or 2.9, and we're going to multiply it by 1/3. Okay, 2.8 times the fraction 1/3, and I get like 0.933333. So that's like kind of close. So it's like 0.9 of a centimeter. And so if I go and put my ruler down here, sure enough, there's 0.9, and look at that, there's point P right there. Okay, so it's just a little bit more than 0.9, and there, sure enough, is point P. Okay, so without having to do that fraction stuff, if you don't like that, if you don't like the, having to do that fraction stuff, that's how we can do that. Okay, you can do it. That's another option you have there. You can measure it. Yes, Cable.
So I used 3 and I got 1. Does that work?
Yeah, that works. Because again, I mean, as long as it found you that point, pretty much, right? Like.
Yeah, like, cause like I feel like the way, and I did it the way you would do it.
Yeah.
It wouldn't go exactly on a point on the graph.
But it was like close enough to 1 where you could say like that's
But
it.
like if you say 3, then it lands on a point.
There you go. So that works. Okay, that's good. Okay, sometimes you have to fiddle with it a little bit. All right, we're going to do a couple more here, and then we'll stop. I know you guys are like all brain dead at this point, but I want to make sure we can do this. Okay, so we're going to skip over here to page 645. Okay, 645. We're going to do 2 more here, just to make sure we've got this down. Okay, you notice here there's no coordinates, so we can't use the run thing like we did before, which some of you guys might be like, thank God, okay? But what we can do is what I just showed you. So for example, if I want to find the ratio of 1 to 3, I'm going to find point P that divides this in 1 to 3. So 1 part over here, 3 parts over here. Okay, so one second. So for example, Chardez, if I want to find the point P that has 1 point to the left of point P and 3 points to the right of point P, how many total, it's not 3 points, 3 parts. How many total parts am I talking about? If I want 1 part to the left of point P and 3 parts to the right, how many total parts would that be then? Sorry? So there's 3 to the right, there's 1 to the left, so 4 total. So 4 is going to be our denominator, and then we want to go from A to B, we're going to go 1 part in. So you're not immediately right here, but back in like example 2 directions, it says, given the directed line segment from A to B, construct the point P that divides the segment. So yeah, I know that's weird so far back there. Okay, so we measure the full distance here. The full distance, oh man, this is like really nice. Look at that. What's the full distance there? 5. So easy. Okay. Do we want to find, does point P go the full distance? What fraction of the full distance does point P go? 1/4. So we're going to do 5 times 1/4, which is 1.25, I believe. Yeah, okay. So we're going to count in here. So there's 1 centimeter. There's 1.1, 1.2. The next one's 1.3. So how should I kind of do like 1.25? If I have 1.2 and 1.3, how can I figure out where 1.25 is then? It's like, yeah, it's in the middle, exactly right. So 1.2, 1.3, 1.25 would be like right there. And there's where point P would go. Okay? There it is. So it's really, the biggest thing here is coming up with that fraction first. Okay? All right, let's do one more here. We'll do one more. We'll do number 9. Oh, sorry. Number 9.
Mr. Wood, instead of doing another problem, can we go over homework or like, or does this one?
So these problems will be like what you see on the homework. Will be like what you see on the homework. So, but this will be that quick, and then you guys can get a chance to like look at the homework and stuff at that. Well, it's gonna be too much time. We're already a little bit late anyway there, Ikeba. Okay. All right. Number 9. Given the directed line segment from A to B, construct the point P that divides the segment in the given ratio from A to B. So I want to divide it in, P should divide it in one part on one side and then 2 parts on the other side here. Okay? So, how many total parts then are we dealing with here for this one, Ramel? For number 9, if I want 1 part to the left of P and 2 parts to the right of P, how many total parts would that be? If I want to go 1 part to the left of P and 2 parts to the right of P, how many total parts will that be? No idea. So you don't know what 1 plus 2 is? 3. It's 3, that's right. So it's just 3. We're going to take this number and this number, add them together. So 3 is the total number of parts. We want to go 1 part in, so we're going to go 1/3 of the way. So again, you just measure AB. Measure AB. AB is again, wow, that's nice, 5 centimeters.
Can you round, if you get something like something repeating, can you round?
Yeah, you might need to, exactly. So in this case, we want to do 1/3 of 5, 1/3 times 5, so that is, when I do that in my calculator here, 1.6 repeating, okay? So that's like, 1.6 repeating is about 1.7 then, okay? You can say it's about 1.7. So, here's 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So it's going to be like right there. Okay, there's point P. That's it. You just measure in 1.7, 1/3 of the distance. What's that? I should have started with these. I don't know why. The book puts the coordinate ones first and these second. I feel like I should have started with these first and then go back to the coordinate ones. Okay? So remember, guys, these are very similar to the ones we saw in the coordinates. You can use your ruler to do that, too. Okay? You can use your ruler to do those coordinate ones, too. So, all right.